Hello everyone, my name's Ashton from Game Genie Labs, and today I'm going to teach you how to make your very own Game Genie codes based off of ROM disassemblies. Now, this tutorial will be split into multiple parts for several reasons, because there's a couple of key factors you have to learn when looking at a disassembly, and other key factors you have to look at whenever it comes to making your own Game Genie code. So to start off with the tutorial, you'll be needing an emulator for this, since I find it way easy to use to basically encode and decode certain values and stuff. The emulator I'm using is SCEUX, and it is a very well-known NES or Famicom emulator. And I'm not going to link the emulator in the description for other reasons also, but it's easily, if you just search SCUX emulator, then that's it. So what we're going to be looking at today is we're going to be creating a code based off of disassembly. Doing this is not that easy to do for beginners, but hopefully I can explain the basics of creating Game Genie codes basically by just looking at a disassembly that someone made of the game. So starting off, let's go ahead and go with the first example for Super Mario Bros. I'm going to teach you how I made some of my previous codes, and I'll show you how to make other codes as well. Right now I'm only focusing on Super Mario Bros. 1 for the NES because I have not found any other disassemblies for any other game. I plan on doing ones for Super Mario Bros. 3 and Legend of Zelda pretty soon. I just gotta find more research on basically the disassembly of those ROMs, but let's go ahead and get into the tutorial. So, making codes uh, is it differs from system to system, even though SNES and NES use 6502 opcode as the as the source engine and stuff. So what you're going to be looking at is, let me just go ahead and switch the screen. I have a page right here. Now I will link this page and the others in the description. But basically, these are disassembly pages. Then you have 6502, and then right here, here's a RAM map that you can find, for example, from Data Crystal. So to start off, let's go ahead and create a code. So what I like to use when I'm going through this disassembly, especially for the Super Mario Bros. 1, is I like to use Control F. Control F is very useful in this case of how this one was compiled. So before I teach you on this disassembly, let's go ahead and credit the people that did it. So this is a disassembly by Doppelganger, and it's from 9 November 2012, and it's for the Japan USA version of the ROM, 3 distinct parts, and I think you get what I mean by that. So in this disassembly, what I really like is that right off the bat, it lists some variables right here. So you'll see that we have several variables right here. In this case, this one says green Koopa. And if you go down, you see other ones, like, for example, this one says, let's see, let's pick one. We're going to do, for example, fireworks, or, just something like that. Now, what you might notice on this is that you have several types of variables right here, but you notice that this one, for example, is 00, and then this one is a %1. Now, this isn't a good example, but if I just scroll down, you'll see, oh, we have enemy ID, and then here's the RAM address right here. But one thing to take note is, looking at this one right here, notice how this says constant, or just CONST. By my understanding, these are variables that are defined in the 6502 processor, and even though they're already assigned somewhat of a RAM address value, they are later defined. So for example, if I search green Koopa, you'll notice that in Control F, we have several results. However, this one, as you can see, Green Koopa is defined right here. And our ROM address D737. Or technically, that this is also referring to the DD1. So going back up, you notice that this says right here CONST. Then you have the EQ, stuff like that. That just means it's defined in the game's code. Now the EQ is just basically applies for anything else. So looking at other ones, like for example, enemy flag. Now flags are a bit of an interesting one. I'll be discussing flags later because it's very crucial that you know what a flag is when it comes to the game's code. But let's give you an example how to create just a simple code, and then I'll just give you a rundown on how it works. So obviously we're not going to be picking a variable from the very top because those are defined. However, you can assign them to different values and actually change up bits of the ROM also. So you could make the Green Koopa turn into, I don't know, like let's see, a red Koopa or something. Just simply stuff like that. And I do recommend looking at a RAM map whenever you're trying to do something like this. So as you can see, this right here, Green Koopa, and the second one is red Koopa, just stuff like that. So this RAM map that's from Data Crystal. And then the 6502, this is for if you want to modify a certain code, and I'll be discussing that also. So to understand how Game Genie Codes work, I'm going to show you either make a 1-line or 2-line, or just as much as you can. So to show you an example, let's go ahead and create a code that changes the level with the music. So I know that the music variable is music data. Now, if you look at this is music data in F5. Now, if you remember, if you're referring to a Game Genie, if you're to a ROM address code, you gotta flip-flop this. So right here, oh yeah, let me just mention one other thing. Notice how this has 4, and then this one has 2. Going to music data, this is technically 00F5 as the raw code if you want to use it as a raw code. And if you're referring to something like this, if I just type 00F5, well, we won't get anything because that's not how it's defined in the ROM. However, what you have to do is you have to flip-flop it, so F500. And you'll notice that you might get some results. It depends on what pops up. So looking back at music data, if that doesn't work, here's one more thing. Notice how this says address/2. That means that there's 2 addresses that apply to this variable. And you can actually understand that whenever you look at the next one, which is music offset, which is S7 right here. So notice how this one is S7, notice how this one is F5. In the next tutorial, I'll be teaching you basically the basics of creating a code based off of a RAM address. So yeah, I'll see you in part 2.